This is an interesting problem involving the ages of grandparents for some high school students. So they took a random sample of 10 high school students who are named for this problem A, B, C, D, E, F, G, H, I, and J. Those are their names. It helps you call them Amy and Bill and Charlie, whatever. They asked them how old their grandmother was and how old their grandfather was and wrote those ages here. Here are the differences. This is the average age of the grandmothers of those, the maternal grandmothers of these 10 students, the average age of the maternal grandfather for those 10 students. The standard deviations, of course, are listed. And it said, construct and interpret a 95% confidence interval for the population mean difference in age of the maternal grandparents for high school students. So let's think about the approach we would have to take, and then I'll walk you through the solution. First of all, it's a confidence interval problem, which means it's an inference problem, which means I've got to decide what kind of procedure I'm going to do. I've got to check the conditions for that procedure. I've got to show the mathematical work, and then I have to interpret that answer. Even if it hadn't said interpret, we want to go ahead and do that part. It's a 95% confidence interval for the population mean difference in age. Since it's for the difference, this is a matched pair because this is Amy's, I think I said Amy, her grandparents, her maternal grandparents, they went together. They match. Bill and Charlie's match. So it's a matched pairs problem. Since I don't know the true standard deviation, it's going to be a matched pairs t-test or a one sample t-test for the difference in ages. And it says we're going to do grandmother minus grandfather. So positive numbers mean the grandmother was older. Negative numbers mean the grandfather was older. The average, of course, being negative means the average age of a grandfather was older than that of the grandmother. The conditions, we need these to be randomly selected. It says they were. I don't have the grandmothers and grandfathers randomly selected because they actually match up. So I have these random students that determined the grandmother and grandfather. Another way of doing it would be to pick 10 random grandmothers and ask them about the grandfather. And that would be the same idea. So I need that random sample. I need the distribution to be approximately normal. And that is the distribution of this list of numbers right here, and I can check it out to see if it's approximately normal. I don't just assume that it is. And then after I've checked that list for approximate normality, and the reason I need approximate normality by checking it is because the sample size is only 10. It's 10 students or 10 pairs of numbers, so I need approximate normality there. And if that works, then I can do the t confidence interval. My mechanics then are going to be x bar plus or minus t star times the standard deviation over the square root of n. I can find the t star for 9 degrees of freedom with 95% off of my chart. Plug those numbers into the formula, get the interval. Once I've got the interval, I'll say I'm 95% confident that the true difference is somewhere, the true difference in grandmother's age minus grandfather's age is somewhere between those two numbers. So let's look and see at how this solution would actually work. First of all, as we said, I'm going to do a paired t-interval for population mean difference. A t-interval for the difference in means. Conditions, we've got a randomly selected sample, and either I have a large sample or a normal distribution or an approximately normal distribution. So 10's not very big, so we need to check the skewness. What they've decided to do on this problem is a stem and leaf plot. That's an easy thing to do. You could also use a different kind of graph on your calculator. And so here is the stem and leaf plot. We do not see any major outliers or big wacky skewness. So I'll conclude the second condition is not violated. Now notice here, there's not a lot of detail, and that's because this is simply a tool. The only thing I care about on this graph right here is the shape, and I guess the shape plus outliers. All I need to do is look at this. I don't really care about labeling it and putting a title on it and all that. I'm just trying to get an idea about the shape of the data. And so since these conditions are met, I'm good to proceed. The mechanics of the test. It's given by this, the average difference. I called it X bar a minute ago, but that's okay. It's the average difference in those ages. Um, I've got 9 degrees of freedom, and they found this number off of the chart. Now notice I got 5.81 here. I want to show you where that came from. There's 5.81. It's the standard deviation of these differences. That negative 1.8 is this number, and so there is the interval. So what does that mean? Well, that means that I'm pretty sure the average difference in ages between the grandmother and grandfather is somewhere in here. We're 95% confident that the population of high school students, for the high school students, the mean difference in ages for their maternal grandparents is between these numbers. And notice how they put it in context right here. I don't know if this applies to all grandparents because the high school students were the ones that were randomly selected. So that's the group to which it applies. Since 0 is in this interval, if this had been a hypothesis test, I do not have convincing evidence that the granddads are older than the grandmoms. If both of these numbers were negative, that would be different. I could say I'm pretty sure that the average grandmother and grandfather has an older granddad, but I don't quite have that here. Okay, so part B says we want to know about the mean difference in age regardless of which grandparent is older. So the interval that we did not address that. Based on these 10 differences, give a value of the point estimate for the mean difference in age that could be used to address the sociologist question. So this seems a little confusing on the surface. Let's look at it again. We want to know the absolute value, essentially, the typical difference regardless of which one is older. So give the value for the point estimate for the mean difference in age. So let's go back and look at this again. So here's the chart. Well, the difference in age here is 1. The difference in age here is 5. The difference in age here is 10. And I want to know the mean difference in these ages. So this is actually pretty straightforward. I just want to look at those numbers in absolute value. Add them up, divide by the 10. The typical difference was 5.2 years without regard for which one was older. So there is a working of the grandparents problem.